Well, it's great to be here today with all of you. This is my first time participating in the workshop, but I've been lurking for about the past 4 or 5 years. A lot of my research uh, focuses on the arts and culture sector and philanthropy and grant making. And so a lot of the work that I do related to curation of data, curation of analytic models is in sort of the public sector government wing of the Big Data conference. So I've had a couple papers published elsewhere in the Big Data conference, but I've always been reading the papers from this workshop to stay involved with the archival science sector, which is really great. So today I'm talking about an idea of applying a method of algorithm auditing to processes that are using archival materials. The idea being that we want to think about not just are we getting a certain result, but how do we know we can trust it? What are the areas of potential issues that might come up when using archival objects, digitized archival objects, for tasks that are using AI? And so today I'm going to be talking through sort of this process, this experiment that I did to sort of explore this at a very surface level, a very simple level, but I think it shows a trend that could be very useful for the field. Earlier this year in March, there was an article written in Wired magazine. This was the start of it, called "Is That Painting a Lost Masterpiece or a Fraud? Let's Ask AI." And this article talked about one particular company called Art Recognition that has their own proprietary AI authentication model that if you give them a digital image, they will use their model to say whether or not that image they believe is authentic by that artist or not authentic. So in theory, that seems like a great idea. You know, maybe we can use AI in this manner to think about the accuracy, the provenance of different archival materials. But can it be that simple? This article was prompted earlier this year, a painting known as LMR Van Gogh. This was purchased in the US at a flea market for like $50 and was subsequently sold to a large, I think, private equity firm who claimed that this is a lost Van Gogh and that it's actually worth $15 million. And in the earlier part of this year, this company released a 400-page report detailing why they think this is a real Van Gogh. Art Recognition came in. They said, well, this is interesting. Maybe we should apply our technology to this and see if we think it's authentic or not. And to my surprise, Art Recognition found that this was not an authentic Van Gogh. But it still made me want to think about the process of, one, how do we think about accuracy of digital objects when pixels might be very different from what the physical object is? How do we account for that? And how might the system be manipulated? When thinking of the history of the LMR Van Gogh, you know, this company that's putting out a lot of information, that's estimated they spend over $1 million to try and say, yes, this is a real Van Gogh, but people aren't buying that. So if someone chose to build their own AI system to authenticate art, could they create a score and say, well, we used an AI model and we used a digital archive to train it, and our model says that this is real? How do we compare those results to the results of a company like Art Recognition has in their services? So I was exploring this and wanting to think, how could I test this? How could I experiment with this? And the baseline idea that I wanted to try was to say, one of the easiest things that I can adjust in a digital image is its resolution, especially in terms of downscaling, making it a lower resolution image. And I wondered, images of different resolutions are probably going to be captured and analyzed by these different AI models in different ways based on what's showing up in those patterns of pixels. As you get lower resolution, you might see different shapes emerge, or the system might identify different shapes than what you would have of a very high resolution image. So I wanted to see how much sensitivity there perhaps is in adjusting image resolution to affect a potential score of authenticity for that digital image. And then from that research question of can we do this or does this affect it, I wanted to think about how can we use a methodical approach of algorithm auditing to probe these AI models, test these AI models to see how they perform and learn more about the models in that way to hopefully be more transparent going forward and improve the tools that we use and the reliance that we might have on some of these different materials. I'll mention to start off, I'm using the term algorithm auditing, and this term is you can think of it as an outgrowth of social science research, field studies, where essentially we want to probe a system that we might not have all access to everything that's going on behind the scenes. And we probe it in different ways with different examples. Maybe you can think of this in terms of resume studies, where you might have a company or a researcher submit multiple resumes to a company and only change the name of the person. Perhaps that name has stereotypical demographic characteristics associated with it, and see, how does it perform differently as a resume if everything else is kept the same. And we can do a similar thing with algorithms that we're using. If it's like, when we say a black box system, if you're using ChatGPT or art recognition, in the case of what I'm going to show here, you can probe these tools to see how the results pan out, even though you don't have access perhaps to the back end. And that would be what we would consider an external audit. I shared a link in the chat. I released a report yesterday with the IBM Center for the Business of Government that looks at this idea and gives a little bit more practical case study example of what it means to audit algorithms in this way. So that might be a useful resource to view. So specifically to art recognition, on the right-hand side here, whenever someone sends an image to art recognition and says, hey, will you tell us if this is authentically by this artist or not? Art recognition will take that image. They will create a collection, an archive of paintings by the artist. So in this case, this image on the screen is by Cezanne. And so art recognition would create a database that had many examples of Cezanne's work, and then they create additional examples from artists that weren't Cezanne to be the counter data to identify things as not by Cezanne. And through their process and through their training, they release a report based to say, we think that this artwork is authentic or is not authentic. Now, as I'm going through this, it's going to sound like I'm picking on art recognition and saying that, oh, they're doing this thing and there's all these issues, all these problems, but it's actually the exact opposite. I'm very appreciative that art recognition makes a lot of their information public. They have this report for this Cezanne is freely available on their website. They have a data set that they use when they're evaluating Raphael images that's freely available. And they've also published 2 different papers in academic venues that describe their models that they're using. So it's not to the point where it's open source because they are a private company based in Switzerland, but I do appreciate that they make a lot available so that I can test things and we can push the ability to improve what's going on using AI with these digital archival collections. So how do I test this? In the papers and reports by art recognition, they provide some documentation about what their models are. They don't provide all the exact weights, all the exact code, but they provide some graphical instruction of what their models are theoretically doing. For one portion of this model, they use a convolutional neural network, which is a method that's going to analyze an image. Looking at this whole image, it's going to go sort of grouping pixels across an entire image, and you could say that it's sort of getting localized information from the image. Brushstroke extraction is the term they use. I don't know that it's necessarily that, but it is getting more localized information in that way. They're using this in that way. They then use a transformer, similar to what you'd be using with ChatGPT, called a sliding window transformer that takes the idea of a window going across an image across all the pixels and um, learning what's in those images using attention in the same way that you have with the language model. So it's just an application of transformers to image data. And their idea with this is that the sliding window transformer provides global composition patterns. So maybe we'll see larger scale things that are emerging in a painting. So it's really useful from these diagrams that they provide is that I can see exactly how they structured their model. They take both of these models to have an input image that you're testing, and they have two paths. They do the convolutional neural network and then the Swin transformer. They then concatenate those, go through a few final layers in their network to come to their final prediction. So it's really great. I'm able to use this information, and I've created, and there's a link in the paper to a GitHub repository where I created a model that is this exact structure. Now, there's going to be differences slightly from what they did in their model documentation, but based on what they provided, I was able to recreate the process by which they use to evaluate their images of paintings. So a big part of this comes into these digital archives, these objects that have been digitized and how they're used in this work. So for me, when I'm training this, I need to have my training data be as similar, hopefully, as to what art recognition uses in their training. For simplicity, I used WikiArt as publicly available data, and it was pretty reasonable in terms of trying to match up with how art recognition curated some of their data sets. I will say that the process of curation is very in depth with art recognition. They hire a lot of art historians to help identify other images of paintings by certain artists that perhaps aren't in a public repository like WikiArt. So keeping that in mind, that even though I'm recreating their process based on how they've described things, their curation process of identifying a lot of those objects is perhaps a little bit more robust. So taking that training information for the Cezanne, I wanted to first look at this painting that I showed earlier to say, okay, I have the report from art recognition. I want to recreate the model and apply it to this image to see if I get similar results to what they found. And if I can do that, I will then apply it to the LMR Van Gogh to see what we get from that. In their description of how they trained the Cezanne model, art recognition used 235 images of authentic Cezanne works and 258 that were by similar artists, but were not Cezanne. So you have sort of a group that gives you authentic ideas of what might be in a Cezanne painting and then an unauthentic. So the idea being, if we feed this a new Cezanne image, it would hopefully be able to identify it as Cezanne. And then we do a similar process for the Van Gogh when we get to that point of identifying paintings by Van Gogh, works by Van Gogh, and then additional ones that were not. And the numbers of images that I used was based on the number of images that art recognition used in their training. But this comes sort of one of the first obstacles with this type of work, is that image resolution can have a major impact on how a model is perceiving it. One of the things that processes that art recognition uses to try and mitigate some of these issues is if an image is of lower resolution, so less than 512 pixels on one side square, they will leave that image alone for training. So for example, if this image were 512 pixels across the bottom, they would use this image as is. If the image pixel, the pixels on one side were from 512 to 1024, they would split that image into 4 different images and use that to train. If they had a very high resolution image where a side is greater than 1024 pixels, they split it into 20 different images to train the model. So each of these segments, so you have a full segment, or you have a quarter, you have a 20th, all have roughly similar numbers of pixels in them. But that's sort of getting different information. Looking at this entirety of this image versus the one component of this particular image, it's going to look different to the AI model. And so that was sort of a question for me of like, well, maybe image resolution is a bigger issue here when we want to think about applying AI to digital collections. So taking my model, I trained it, found that I got pretty high accuracy. That would be the green line. These were the metrics that art recognition primarily used in justifying the performance of their model. But accuracy, getting up to about a little over 90%. That's great. I felt confident with the model. Then I'm going to audit it. So my process for auditing in this case, you could also think of this as a sensitivity analysis, or you could argue that this is a counterfactual in some way, that if I change only one thing, the resolution of the image, how does that change the output evaluation of whether a work is authentic or not? So as we look at this chart, here on this left side, we have this gray box of 8%. That is reducing the resolution of the image that we saw here down to 1 pixel wide. So just a gray box of 1 pixel. When we put that 1 pixel image through the system, we get an authenticity score of 8%. That's great. Nobody would assume that a single pixel could represent that, yes, this is a Cezanne. But one thing that becomes very tricky is that when we look at an image that is 15 pixels wide, which is what this image looks like to us, that got an 86% score on whether this was authentic or not. And I think everyone would agree that if you saw this image and someone said, yeah, this is a Cezanne painting, you'd say, well, I can't use that to justify that, say that this is actually a Cezanne. But remember, if I am someone who is privately creating my own AI model and I say, my AI model said that this painting was 86% accurate, then we have sort of a truth issue of what does it mean for this to be authentic, especially if the individual isn't sharing information about their model, or they're not sharing that they tested it on a 15 pixel wide image. As we continue to increase the resolution, you can see you have some increased percentages up to 90% here, and it stays pretty consistent. But this also is showing these different shaded regions are those different segmenting, patching illustrations, where when we jump from a low resolution to a medium resolution, the performance of the model is very different. It's consistent within that band, but it's very different from the other bands. And then when we look at the high resolution area, again, it's consistent generally within that area, but very different from the other bands. So this idea of image resolution, even though it's a very simple idea, could have major impacts on understanding the truthfulness and the accuracy of applying AI to this archival material. So I've applied that to the Cezanne. I then did a similar process to the LMR Van Gogh to say, if I'm a bad actor that wants to prove that the LMR Van Gogh is real, could I do that with this type of AI model? So I did the training again, about 90% accuracy, good to go. And when we look at the results, interestingly here, this 1 pixel image from this model comes out as 98% accurate. Again, none of us would say that this single pixel would justify a 98% accuracy score. So there still has to be this human element to be able to evaluate the logic, the reality, the possibility that that is a real evaluation of a real image. And interestingly, we still have some of that same area. Each area is slightly different, but as the image gets higher and higher resolution throughout our experiment, this is just a simple regression line. This orange line shows decreased likelihood of this being a real Van Gogh. So again, this isn't to say that you shouldn't use AI to do these things, but we need to ask questions about what are we using AI to validate? If we're trying to create metadata for something, how are we thinking about the accuracy of that metadata if something's being manipulated in some way, maybe on purpose, maybe by accident. So by doing sort of these structured tests of the AI system, we can understand how it performs a little bit better. So in conclusion, yes, AI authentication in this case can have very different results for classifications based on just changing something as simple as resolution. So you can imagine you could change many other things as well, but this is one that is very important. And then additionally, this idea of algorithm auditing with these digital collections becomes a useful tool within this computational archival science space that we can apply it in different ways to test different things that we're thinking our AI models are doing. And lastly, I continuing this research beyond just these single paintings, but I do want to acknowledge that Art Recognition within the past 10 days released this report on framework for responsible use of AI in art authentication, where they specifically mention image resolution and careful how it needs to be careful. So I shared the paper with them ahead of time. So I like to think that the research of this group is contributing to this discussion of more transparency, but I won't be as vain to say that it's because of this paper. But it's been really enjoyable to work on this and just explore this really interesting topic, how it relates auditing to these digital collections.